Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about the AC3 phase 2 pole synchronous motor in Power Engineering Laboratory 3, which is MMEA. First of all, I want to introduce myself. My name is Muhammad Afiq Afandi bin Muhammad Hussein. My metric number is DE190109. In this part, I will explain about the star connection of the motor. Based on this table, it shows the data collection for the stator. There are several parameters that we observe in this activity, which are speed, voltage, current, power, and power factor. The load will act as a manipulated variable that influence the value of all the parameters. First of all, we observe the voltage parameter first. So in this voltage parameter, there are single phase and the three phase. The single phase value will remain the same when the load increase. The value will approximate around 145 until 147. The three phase also same. It does not change the value when the load increase. The value will remain the same from 248 until 249. Next, for the current, we also have the single phase and the three phase. For the single phase, the current will increase in line with the increment of the load. Same goes to the three phase current. The current also will increase when the load increase. The next one is the power parameter. In power parameter, there are also single phase and the three phase. For the single phase, the power increase in line with the increment of the load. This is because the current will influence the value of the power. The power must be increased to maintain the speed of the motor, which is the 3000 RPM. The last parameter is the power factor. The power factor for the single phase and the three phase also increase in line with the increment of the load. At the 0.8 Newton meter of load, the motor will give no value or uneven value. This is because the motor will achieve the pull out situation. The only load that it can be handled is 0.8 only. Next, for the table 5.2, it shows the data collection for the armature. There are two parameters that we observe in this activity, which is the DC voltage and the DC current. So, as we can see, the DC voltage does not change even the load of the motor is increased. Next is the current. The current also remain the same between 2.5 until 2.6, even though the load of the motor increase. In table 5.3, it shows the calculated power for the star connection. So the horsepower in this table, it can be obtained by calculate it from the three phase power. So from here. So 1 horsepower is equal to the 748 watt. So we can divide the three phase power to the 746. So the answer will get here. So for the first 0 Newton meter, it will get 0.15. For the 0.1 Nm, the horsepower is 0.15 HP. For the 0.6 Nm, the horsepower is 0.17 HP. For the 0.3 Nm, the horsepower is 0.23 HP. For the 0.4, the horsepower is 0.30. For the 0.5 Newton meter, the horsepower is 0.35 HP. For the 0.6 Nm, the horsepower is 0.38. And the last one is 0.7 Nm and the horsepower is 0.42. So the shape of this horsepower is increased from the 0 Nm to the 0.7 Nm. Next, I will explain about the equipment layout for the star connection. So this is the connection for the star. There are some main parts that we need in this connection, which is the three-phase supply, voltage, current, power, power factor, DC voltage, DC supply, DC current, digital DC, and the digital DC for voltage. So we connect for the three-phase supply first. So from the three-phase supply, the red, yellow, blue, and neutral, we connect it from the for the voltage meter here. So from the voltage meter here, it will connect series to the current, power, and power factor. So the red one will connect in series from here to here, and the yellow one and the yellow, blue, and the neutral will follow like the red one. So from here to the current meter, next one is to the power meter, and the last one is for the power factor here. For the output at the power factor here, the three phase line here, red, yellow, blue, will connect at the stator of the motor. So for the red, it will connect at the red point here. For the yellow, it will connect at the yellow point here. And for the blue, it will connect at the blue point here. So for the neutral, will connect to the common point. So the common point will collect all the red, yellow, blue from the stator. We connect to the neutral point here. Okay, next for the DC supply. So the DC supply will connect to the rotor part at the motor. So from the DC supply, it will connect to the DC voltage for the meter first here. Next, the DC supply also supply to the DC current, and the DC current output will connect to the digital DC. This is the analog and this is digital. Next, the output for the digital for the current, it will connect to the positive part at the rotor. So for the negative part, the output of the rotor, it will connect back to the DC supply here. Okay, next, at the output of the analog of DC voltage, the negative terminal at the DC supply, and from here to the the negative terminal will connect at the DC digital DC voltage here. So the output will connect it at this point here. So it will complete all the connection for the star.
Good day to doctor and my team member. I am Balarajan Sanasi and my metric number is CE190056. Today I will present about the activity 7, which is data collection of a three-phase synchronous motor connected with delta connection. Then I will present about for the activity 8, wiring connection layout for delta connected synchronous motor and synchronous motor, and for overall equipment layout diagram. Let's begin. From this table, find point 4 show the data collection of stator, the delta connection. We measure the voltage, current, power factor for various load torque, which is from 0 to 0.8. And for the 0.8, the motor will stop rotating due to it achieve the maximum torque. Then this is table 5.5 show the data collection of emitter, which is the excitation DC supply. The excitation DC supply supplied to the rotor of a three-phase synchronous motor, which is the DC supply supplied the rotor parts. from the DC voltage. From here, table 5.5 show that the voltage and current difference which varies load torque, which is from 0 to 0.8. Besides, in table 5.6 shows that we have calculated the horsepower for delta connection synchronous motor, which varies speed from 0 to 0.8 by using the three-phase power in here, which is 101.1 until 222.7 watt. For this calculation, step shown below, which is for load torque of 0 Newton meter, we get 0.14 horsepower, which is for 101.1 watt. This calculation show for load torque of 0 to 0.8 Nm. Then, for the overall table observation, identify that the synchronous motor speed has approximately constant speed of 3000 rpm. For the load torque of 0 to 0.7, due to the rotor capture the flux speed, logs it with the status rotating field. Then the rotates at the speed of 3000 rpm. Then the motor stop rotate when the load torque about 0.8, which is the motor unable to work with the abnormal load torque. Then the consumption of three-phase power and horsepower increasing along with the applied load torque future mode. Due to the motor specification, the motor function in a good condition at nearly the constant speed of 3000 rpm, with a stable power factor for the load torque of 0.2 until 0.6. Then I will present about the activity 8, which is the wiring connection for three-phase synchronous motor and also for the overall layout diagram. Let's begin. From this wiring diagram, we can see that the DC supply is supplied to the rotor parts of this synchronous motor, which is the carbon brush, and the three-phase supply in delta connection supplied to the motor from red line to R, and the output is R dash go to the Y phase, and the output of Y dash go to the blue line. From blue line enter to the stator coil, then the output of B blue dash, which is go to the common and connected with the red line. And for the neutral part is not connected due to this is a delta connection. Okay, next, this is the overall equipment layout diagram. From here, we perform the delta connection. Firstly, from three-phase power supply entered to the voltage measurement meter, which is digital, along with current meter, power factor meter, and lastly, connected to the three-phase synchronous motor. Then for the DC excitation, this is the DC power supply supplied to the rotor parts of this motor. The DC supply from positive entered to the voltage measurement tools, and then entered to the positive supply entered to the current, and the output of the current go to the digital ammeter. Then it lastly connected to the positive terminal of motor part, which is the rotor carbon brush. We can see from here the voltmeter, either analog and digital connected parallel version, and the DC ammeter from both digital and analog connected series. Then the operation of this overall system, which is firstly we will turn on this motor drive. This motor drive is supplied from the DC supply. When the motor drive achieve 3000, we can turn on the AC supply to supply the stator and rotor parts. Turn on the both DC supply and AC supply, three-phase supply, which is the data connection. Then we will adjust the load torque, which is from 0 to 0.8 Newton meter. Then we will record the voltage, AC current, AC power, and power factor, as well as the DC current and DC voltage. That's all for me. Thank you.
Assalamualaikum and good morning. My name is Imran bin Muhammad Ghazali, matric number CE190118, and I'm going to explain about the graph of our group. Okay, first, this is the calculated horsepower versus the load torque graph. From here, we can see that the data is increasing for both star and delta, but they drop at 0.7 load torque here because this is the breakover torque. And this is our data, by the way, that we have input into the graph. Okay, I move on to the next graph. This is our AC currents to the load torque graph. Okay, in the graph we can see that that is red, yellow, and red, yellow, blue connection phase. And we see here, we can compare here that the star one uses less AC currents compared to the delta. And again, this is the breakover torque, so there is a spike here. Okay, this is data that we have used. Okay, finally move on to the last graph, which is the DC current versus the load torque graph. And we can see here from the graph, the star and delta is almost proportional to each other, because the range of the DC current is from around 2.5 here to 2.6, and this again is the breakover torque here. And this is our data that we have used. Okay, that is all for my part. Thank you.